Hi there. Welcome everybody. This is a re-recording of the SQL Server 2012 High Availability and Disaster Recovery webinar. My name is Jeff King. I'm a SQL and BI platform architect working for Microsoft. I have with me on the phone today a colleague, Josh Robinson, who's also a SQL and BI platform architect. Josh, I don't know if you just want to quickly introduce yourself.
Yeah, along with Jeff, I cover our SQL customers. Specifically, I'm focused on the Mid-Atlantic, whereas Jeff is focused on the Greater Southeast. But again, we have the same role with different territories.
Okay, thanks, Josh. So I'm going to go over what the meeting objectives are today. So we're going to take a look at obviously SQL Server 2012 and what always on and high availability and disaster recovery means inside of SQL Server 2012. It's obviously changed quite a bit over the last 10 years. So we're going to also take a look at sort of some of the legacy architecture and the legacy capabilities that were part of older versions of this product. Everything from database mirroring, log shipping, replication, some of those things. And we're going to talk about how those have changed with SQL Server 2012 and really where the benefit and advantages are within the application as far as, over the last 10 years and the changes that have been made up to this point. And we're going to go through a demo that will actually we'll stand up and configure a 3-node high availability cluster. We'll use SQL Server Always On for that. And then also as part of that, Josh is going to go through some really great slides on sample topology. So, taking your existing environments and what those look like and actually turn them into a new Always On SQL Server 2012 enabled high availability and disaster recovery solution. So we've already been through introductions, but I just wanted to point out that we've got our email addresses, jeffrey.king@microsoft.com and josh.robinson@microsoft.com. We've both been consultants in our previous lives and have worked together actually prior to even coming to Microsoft on different projects. So, we're not just going through the manuals and regurgitating this information. This is actually, stuff that we've worked with. We've been there and have gone through the pains of configuration as well. So we hope to bring some of that insight, when we have some of these conversations with you. And then just to quickly review our gov.sql program. So this is the first session in the series of 3 that we're running for the month of May. And we're launching this gov.sql training program. And the idea behind this is that we know that there aren't a ton of free resources and resources out there that you can connect with from a developer standpoint. So we wanted to create a program that allowed you to have access to both Josh and myself. And it's an opt-in program, so we're not going to be sending you spam. We're not going to be doing things that we shouldn't be doing. But it's really about giving you the resources and access to the resources that you need on a day-to-day basis, and also coming up with some ideas around how you use the products. So where you get to a place where you've got real-world business problems, and we can help walk you through solving some of those through some of these webcasts and training events. And if you'd like to sign up, please email me, jeffrey.king@microsoft.com, and I'll make sure you're included. So before we get too far into the always on conversation, I did want to mention just some of the high-level features of SQL Server 2012. And I like to show this slide because back in the day when I was a consultant, we were working with SQL 2000 and forward, but when SQL Server 2008 came out, I never really understood why we have the R2 or the second release of that product. I never really quite got why they didn't actually just name it the next version. And that, of course, I thought that until I actually saw the 2012 release. And I figured out pretty quickly that there were just so many features that have been baked into the new code base or the new product release that really started to make sense to me why they had the 2008 R2 versus 2012. And across all dimensions of our product capabilities, there's been some really big changes. From high availability, which we're going to talk about today, to scalability and performance. You know, we've got new compression components that are actually built into the tool using some of our technology that we had in Excel. So the X-Velocity compression engine is now actually built into our code base from a SQL Server engine perspective. You know, we've got some new security and manageability components you know, that allow us to track users and some of the, you know, events that occur in the system on a much more finite level. So also, you know, we've had some additional BI components as well, which are huge. The addition of products like Power View, or features like Power View, I should say, that are, you know, directly integrated inside of our Office products as well as inside of SharePoint as well. So I won't go through each one of these, but I did want to just show this slide to illustrate that, you know, we really do have a very, you know, diverse product now, you know, and compete very, very closely with Oracle. You know, and really, obviously, the big difference between us and them now is no longer features, but it's all about the cost. And we are, you know, you get a lot of bang for your buck with SQL. So let's talk a little bit about some of our legacy capabilities from a high availability and disaster recovery perspective. Now, you know, these have been around for many years and have sort of laid the foundation of SQL Server. And you know, I've got sort of the four primary types that come as part of, you know, the product and have been developed over the last few years. Obviously, all of these are available within our SQL 2008 product. But the first is failover clustering, our second is mirroring, you know, the third is replication, and then finally log shipping. And each one of these have their own set of unique features. You know, server level failovers for clustering, where you've got two servers, you know, with one interconnected SAN, or sorry, the two servers are interconnected and sharing a database that's served up through a SAN. You know, so sort of a less complex, you know, way to fail over at a server level. You know, and then you go into sort of the more granular approach with mirroring, where you can actually have individual databases that fail over between servers with mirroring, replication, and log shipping. A couple of these scenarios only support automatic failover. You know, one of them, or actually, sorry, two of them support server level object failover as well. So really, the point of this slide is not to go through each one of these, but to really show you that we really, up to this point, there really wasn't an all-encompassed solution that brought all of these capabilities together. So let's quickly look at the high availability and disaster recovery architecture and what this means. And this is, you know, fairly basic stuff, but I wanted to just go over this. And what we're going to do is we're going to bring this all together with Josh's slides, which will show you, you know, how this all plays together in the new world, in the new always-on world. So with SQL Server failover clustering, as I mentioned just a few seconds ago, and you've got two servers. You know, on top of those servers, you have a Windows cluster. One of the servers acts as an active node, and one is passive. And you know, you have your SQL Server instance that is shared sort of across these, and the server B is ready to pick up the load if server A fails. You know, the underlying storage mechanism is always going to be a SAN in this case. You know, and this allows them to basically use the same disk structure, you know, on failover. So it's an active-passive environment. One of the things that historically, you know, has been part of SQL failover clustering is that it's always been very difficult to set up geographic failover. You know, and the primary reason being that, you know, Windows failover clusters, you know, built out across subnets just don't play nicely in terms of, you know, having one single failover cluster. And some of those things have changed in the new world, which we'll review in just a few minutes. So my next slide covers SQL database mirroring and log shipping, and this is where you know, we've got sort of it's a more of a granular level than failover instances. You know, in this case, you've got a SQL Server principal server. You've chosen a database that you want to have mirrored and copied over to a mirror server. You know, we have a couple of different capabilities in terms of ways that copy occurs. The underlying mechanism that drives everything is, of course, log redos. So, you know, everything that happens on the primary server is then rewritten on the secondary server. And depending on whether that's synchronous or asynchronous, you know, that sort of determines at what schedule those log rewrites happen. If you've got a synchronous environment, And that synchronous means that there's basically going to be no data loss between the two servers. The log redos have to occur on the secondary server before they're committed on the first server. And so that ensures that if the first server goes offline, that the second server will have an exact copy of the data at all times. Now, of course, there is some latency, that you have to worry about with this type of backup process. But for the most part, it's sort of the core foundation of what mirroring and is in the SQL Server world. In addition to that, if you've got database mirroring in place, there really are some disadvantages a little bit in terms of you need to have a SQL Server witness server if you want to have automatic failover. So automatic failover just out of the box does not come, you don't just turn on mirroring and then automatic failover automatically occurs. It's you really need to set up that third server. So if you're looking at more hardware to manage, you've got additional licenses that you have to buy to make that all work together. And in this view of the world and this HADR configuration, we've added log shipping as well. So you've got your mirror set up locally for your high availability, and then in your disaster recovery center, you've got your warm standby, which is using log shipping. And log shipping is very similar to mirroring as well. The only difference is that you're basically, you define the schedule at which the log gets captured, sent over to the disaster recovery center, and then is rewritten into or recommitted into the actual database environment. Okay, so let's talk a little bit now about availability groups and what's changed. So the biggest thing, I think, and the nicest feature that comes wrapped into this, or the nicest benefit, I guess, that's wrapped into this, is that along with bringing together some of these components. So you recall that first slide that I showed where we were comparing all of the different features of each backup solution that we have. Essentially, by bringing these all together using something called an availability group, we've actually increased failover by 2 times. So we've reduced downtime by half. And this is a sort of a stepping stone for us in terms of how we've moved into the new world of high availability. So we're talking about greater uptime based on these types of configurations. What we can do now is we can take a set of databases that define our tier 1 mission critical workload. So if you've got a big server that's running a whole bunch of different databases, you can just define a specific group of databases and fail those over to a secondary server. So you don't have to fail all of the databases, just that one particular group. So that could be your tier 1 mission critical workloads only. And then the benefit there is that you don't have to have a server that is going to support an entire instance. So instead of failing everything over, you just fail your select databases over, and you can fail them over to a lower powered server. Also, there's no longer a need for SAN storage, so you can actually use direct attached storage with your environments now, which when you think about the cost of managing hardware, that really impacts how much you're spending and what your IT budgets are. So just to review the final slide that I'm going to show you with features here, what I wanted to do was just show you that our new always-on solution really does bring together all of the components across the dimensions that we have, in our older legacy architectures for backup and recovery. And you can see here in our always-on category, we've got server level protection, database level protection, automatic failover. We support server level objects, so all of your security and all of the underlying store procedures and views and all those things will actually fail over as well. We also support readable secondaries. So if or you've got a disaster recovery solution in place, obviously you're not typically going to be using that for anything because it's your DR environment. We now have the ability to start using those licenses from a readable secondaries perspective and really have very granular control over those secondaries and what we're doing, within them from a read-write perspective. And then, of course, we also support multiple secondaries now. So it's not just about having one. We can have multiple replicas, spread out in different locations. So to review, I'm not going to spend too much time on this because we're going to go into a lot of this in detail during our demo. But some of the changes that we've made and some of the really nice features are we have a total of up to 4 secondaries per environment now, where 2 of those secondaries can be synchronous, and the other 2 would obviously be asynchronous. From an integration perspective, we've also got the automatic failover capability that I mentioned earlier, where we're using something called a virtual network name, and this is basically gets written into or a configuration component that gets written into your DNS system. So you would have basically a name that your application would connect to that would have an IP address associated with it, and that name would sit in front of your failover cluster in your always-on solution, and depending on, regardless of what happens to the underlying servers, whether if one fails and it fails over to the secondary server, the application that's going to be seamless, and it's going to be a seamless failover because it's pointed to that virtual network name, and therefore automatically the DNS will just reroute and pick up the new connection at the secondary server. So and we're going to take a look at how this all works during the demo. Also, as part of this, we have some new dashboards that we can look at, that give us a very nice picture and very clear view of our environment health, and we can drill into some of the details behind, performance of each server. We can also initialize things like failover and some of the, if you're patching servers and you want to do some of the manual components, it can all be done through this dashboard that we've got now. As I mentioned, this is all about having active secondaries as well. So from an efficiency perspective and utilization of your secondary hardware, we have the ability to support readable secondaries, and those can be running your reporting, those could be running backups, and what the design here is, it's really designed to reduce workload on your primary server. So if you've got cubes that you need processing, or you've got a data warehouse, you're running some ETL to build, this can all be done on your secondary servers. One of the nice things too from a configuration perspective and how the environment fails over, traditionally when we talk about failover and SQL Server, especially with failover cluster instances, we've been dealing with quorum, and where we've got the servers in a cluster are all voting on the health of the environment. Now we actually have a new failover policy that sits inside of the always-on application and allows us to actually configure the failure condition level. And this doesn't need to be, all of these things together. It can be any one of these things. We sort of design the failover rules. So it's almost like a set of business rules that define when the system's going to fail over. So it can be any one of these things. It can be an accumulation of 1, 3, and 5 on this list if we wanted. So where we've got a SQL Server process, we've got an orphan spin lock, and then a deadlock. And if all of those things are true, then we fail over. So it really gives us a lot more finite control over what defines failover for us. Also, as I mentioned, we have a health dashboard that allows us to go in and actually determine the health of each server in our cluster. And we can you'll notice that there are links associated with each one of those servers, so you can drill into that and do some additional things behind the scenes. And what's not showing in this is that, which we'll see in just a few minutes in our demo, is we have the capability to actually fail over manually and start a different, basically, configuration tasks within this view on the entire cluster. So to quickly review how an actual failover would work, I've got a diagram here that shows how a configuration, or just a very basic configuration, would look like. And this is actually very similar to what we're going to build in our demo today, but it has all of the different components. And the most important one, I think, is the virtual network name is what I want to draw attention to here in terms of the changes from what we used to do to what we're doing now. So you can see we have server A, which is our primary database server, so our transactional workloads are writing to server A. Server B is our secondary, our replica in our configuration. Server C is a third replica that's acting as a secondary. And you can see within server A, we've got our availability group that's built on top of our database, and that's tech AG1. And then it has a virtual network name attached to it. and actually pointing all of the traffic essentially to this server to manage its rights. So let's imagine that the server fails. So we have this nice X that shows up, and all of a sudden we can't write to this database anymore. So what's going to happen is automatically the environment is going to recognize that server A is offline, and server B needs to pick up the load. And so the tech AG1 availability group will kick over to server B, and there's a mirror of that particular database on server B, and then the virtual network name will then point to server B. And so from an application perspective, it has been totally transparent. So the application doesn't know that anything's actually changed, other than there might have been a few failed writes while it was trying to redo its connection or redo those writes. So the server B picks it up. Server B is, of course, in a synchronous state, so we won't have lost any data when this occurs. And now we're ready to get going again. So let's talk a little bit about the readable secondaries and what these are actually doing as well, and how the roles can actually switch between these. And this is really the point of this slide. Is one of the nice things about AlwaysOn is that where you've got a primary and secondary nodes, the nodes themselves can actually flip roles very, very easily. So in this case, we've got a primary server and a secondary server, and we've got some database log synchronization that's happening between the two servers, and we're running our reports off of instance B. So the primary is capturing all of our transactional workloads. We've got some reports, so a secondary workload that's not stressing our primary is now running off our secondary server. So let's imagine that we have a crash on our primary. Now, regardless of the fact that we're running workload or a read-only workload off of our secondary server, what's going to happen from a configuration perspective is that secondary server is now going to become our primary. So it's going to fail over. You can see that the instance B has now become our primary. And then basically going to reverse roles where the database log synchronization will be happening from instance B over to instance A. And you can see that instance A has now picked up the reporting capability that we had originally with instance A. So they've just totally reversed roles. And this is really nice in that when the environments come back online and you figured out what's going on, you solve the problem, you bring that primary server back up again. Doesn't necessarily need to be failed over again to get it back to its original state. We can just move forward in this manner. So I'm going to hand off to Josh here in just a second, but I wanted to quickly just review what a traditional high availability disaster recovery architecture would look like. And this is actually indicative of a customer meeting that I recently had where we've actually deployed AlwaysOn. And Josh is going to talk about the different configurations that we would support to replace this in just a second. But this is essentially an environment that uses SQL failover cluster instances. And we've got a primary data center that has 2 nodes, and then we've got a secondary data center that has our DR environment. There's 4 servers across our entire cluster. 2 of those servers have, there are 2 Windows failover clusters that have to support this. You recall that, we don't support cross-subnet Windows failover clustering in the older versions. And so, this has always been a bit of a maintenance headache in terms of, keeping 2 clusters alive, 4 servers. We've, got multiple SQL Server licenses in this case, and then SAN replication that exists between our shared storage, to keep those synchronized as well. So let's take a look at how this changes in the new world of AlwaysOn. Josh?
Yeah, thanks, Jeff. So I'm just going to share my screen. And you should see a slide come up. And so Jeff has been introducing AlwaysOn from a high-level perspective, and what I'm going to actually show are some of the reference architectures. Now, I'll be coming at these from a high level, but if you'd like to get implementation details, low-level, technical details, all of these are available I'm just going to click this pin, in various white papers
Josh,
that have been published.
If you could reshare, Josh, I'm actually not seeing the
yeah, of course.
For a second.
Let's see. Just going to quickly stop sharing and share my screen again. And just let me know when you see it, Jeff.
Okay, I will.
And from my side, it looks like it's coming across. I don't know.
Okay, that's great. I've got it.
Good. Yeah, and again, so a lot of the technical implementation details, the actual steps you would take, some of the technical nuances are all available in a series of white papers that have been published by our SQL CAT, or Customer Advisory Team. But I'll just be approaching these from a high level. And the three reference architectures that I'm going to look at will exclusively be using our AlwaysOn technologies, and those are, once again, AlwaysOn failover cluster instances and AlwaysOn availability groups. So the first reference architecture exclusively uses SQL Server failover cluster instances. Now, this is something that's been around for years, and many of our customers have successfully implemented failover cluster instances. There are some interesting updates in SQL 2012 for this architecture, however. And just to lay out what it looks like from a high level, in our example, we've got 4 nodes, 2 at the primary site, 2 at the remote or the disaster recovery site. And as you can see, there's a single Windows Server failover cluster that all 4 of these nodes belong to. In the past, to do geodiverse or multi-site SQL Server failover cluster instances, you would have had to do a stretch VLAN. So with SQL 2012, you no longer need to do that. So that's one of the things that makes this architecture and this topology much more accessible in SQL 2012. Another thing that is key to this architecture is storage replication. So basically, this is provided by the storage vendor. So if you have a SAN vendor, you would use SAN storage replication. And this maintains a copy of the databases at each of the sites, whether it's the primary or disaster recovery, or even if you have a secondary disaster recovery site. Even though there are separate storage volumes at each site, SQL Server looks at this like a shared storage solution. It's not aware of the fact that behind the scenes, storage replication is taking place. So all of these nodes are seeing the exact same thing as far as SQL Server is concerned. One second, okay. And just some important attributes of this solution. So the unit of failover for both high availability and disaster recovery is the entire SQL instance. So one second, I'm going to page down here. There we go. Okay, now the whole slide should be visible. So the entire SQL Server instance is the unit of failover. So that includes SQL agent jobs, that would include logins, that would include all databases, not just some databases. So this is very much an all or nothing proposition. The database is required to be in, it doesn't matter whether the database is in full recovery or simple recovery mode. So if you're looking at setting up disaster recovery and high availability for a data warehouse, which may use simple recovery mode, then this solution might be the right one to choose for that. Some of the other solutions require full recovery mode and maybe less desirable for like a data warehouse or a scenario like that. And another interesting thing that's almost something to be aware of that may not make this desirable for all situations is that the DR copy of the data is not readable. So as you look at these 4 servers, active, passive, 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 the only server that you can read and write data from and to is node 1. So nodes 2, 3, and 4 are just waiting for that failover, waiting for that time when they might be needed. So that is a possible downside to this architecture that we'll address in one of our further reference architectures. Jeff, are the slides coming across clearly still? I just want to confirm that. Okay, good, they are.
Hey Josh, yeah, I'm seeing them fine.
So the next architecture that I'd like to talk about, moving away from SQL Server failover cluster instances exclusively, this one will focus exclusively on availability groups for both high availability and disaster recovery. So just to set up the servers, you can see we have 3 nodes. Nodes 1 and 2 are at the primary site, and node 3 is at a remote or disaster recovery site. So the one of the highlights of this architecture is that, let me just page down here. Oh, I should mention that all 3 nodes would need to belong to the same Windows Server failover cluster. That is one of the underlying requirements for both failover cluster instances and availability groups. And then just to paint the rest of this slide on the screen, you can see we have a synchronous replica set up on node 2 and an asynchronous replica set up on node 3. And just to talk about this architecture for a second, one of the highlights is that it's based on a non-shared storage. So unlike the prior instance where you do have shared storage, even when it's at the remote site, SQL Server, is basically fooled into thinking that it's shared storage, although behind the scenes you had SAN replication. This is purely 100% based on a non-shared storage solution. And the reason for that is that each SQL Server in the topology has its own copy of the data, and it doesn't need to access shared storage. So in this architecture, you can see that we've got multiple secondaries, in this case nodes 2 and 3. And the first, as I mentioned, is configured to be a synchronous replica, and it's located in the same data center as the primary. The second replica is asynchronous, and as I mentioned, it's in our remote data center. So already you can see some differences from database mirroring. Unlike database mirroring, which only allowed a single replica, with always-on availability groups, you can configure up to 4 replicas in addition to your primary. Any of those replicas can be configured to allow read-only workloads, and Jeff is going to demonstrate that. And there's great benefit there because you don't even have to take them offline to read from them like some of the other high availability and disaster recovery technologies. You can read from them while they're online and while they're being updated. The types of read activities that you might use them for would be to take backups, to load a data warehouse solution, or even to do online transactional reporting against your production system without affecting your primary, node 1 database. If you were to look at a solution like this before SQL 2012, you probably would have implemented database mirroring for the local high availability and log shipping for the remote disaster recovery. And so, you would have had to use multiple technologies. So with SQL 2012, you can leverage just a single technology, availability groups, and then you get all the benefits that I mentioned, multiple secondaries, read-only secondaries, and the ability for automatic failover. This slide shows just a simple scenario with 2 data centers. I think it's important for me to note that there are a lot of variations to this architecture that you could implement. You could have multiple data centers. As I said, you can have up to 5 replicas, including the primary. The unit of failover for this is the database or a group of databases. So unlike failover cluster instances in which you fail over the entire SQL Server instance, you do have more granular control in this case, although you would have to implement something outside of availability groups to bring jobs and logins and those types of things over. Objects that exist at the server level would not be failed over as part of the database failover process. Any databases that are set up to have a replica do need to be in full recovery mode. So that's just another thing to note here. The last reference architecture that I want to highlight today, it starts out looking a lot like the failover cluster instance architecture with primary and secondary site, nodes 1, 2, 3, and 4. And as you can see, a shared storage solution at each of the sites. However, that's where things change. You do still have a Windows Server cluster. However, that is used for the availability groups in this case. In terms of the SQL Server failover cluster instance, you'll have 2 of those, one at each of the data centers. And then what happens is you lay availability groups on top of those 2 SQL Server failover cluster instances, and rather than using a third-party storage replication solution, you can actually leverage availability groups to send the data from the primary site to the disaster recovery site. Now, this is interesting in a couple of ways. So one of those ways is that you don't have to get involved in a high-end storage replication solution. You can use out-of-the-box SQL Server technology that Jeff will demonstrate to set up the synchronization of the replicas. Another thing that you basically unlock with this topology is that secondary, that DR site, is now a readable replica of the primary. So whereas before you had nodes 2, 3, and 4 that were passive, in this case you now have node 3, which is an active read-only copy of your primary database. So you have a lot more value there. Let me just page down in the slide. So again, some of the benefits of this this solution would be that the unit of failover for the local high availability is the SQL Server instance. The unit of failover for the broader multi-site disaster recovery solution would be the database. So if you were to fail from the primary site to the disaster recovery site, you would be failing the databases over. You'd need to have a second tier, solution in place to bring SQL agent jobs and logins and other server level objects. So there is a little bit more configuration that would need to take place outside of just the availability groups between the 2 sites. And we have white papers that cover all of that. The databases would need to be in full recovery mode. And as I mentioned, that DR site now becomes a potential active read-only replica that you can perform work on. And like the other solutions, there are a lot of variations of this topology. You can have multiple data centers. I'm showing just 2 here for simplicity's sake. You can have multiple replicas. You can have more than 2 nodes in each of the failover cluster instances. If you wanted to have 3 nodes at your primary site, you could absolutely do that. Not all of the replicas need to be failover cluster instances, so maybe at the primary site you would have a SQL Server failover cluster, and maybe at the DR site you would have a smaller failover cluster instance. But then maybe you would have a third site that would just be a single SQL Server. It would not be a failover cluster instance. So there's a lot of flexibility there. And also you can have multiple availability groups. You may have some databases that don't need to have disaster recovery. You take backups and maybe you don't need full disaster recovery between sites. So you can choose not to include all databases in the site-to-site disaster recovery availability group solution. As I mentioned, all of these are available. There's white papers that cover these in great detail and actually cover the implementation steps should you wish to do those in a lab or in your production environment. Okay, Jeff, back to you.
All right, thanks, Josh. That was a great overview. So what we're going to do now is we're going to go ahead and get into the actual demo itself. So I'm just going to spin up my my virtual environment here, and let me go ahead and share that with you guys. And Josh, if you want to just let me know when you can see that.
Yeah, it looks like it's still loading, Jeff.
Okay.
And it's just come across on my screen.
Okay, Thank you. All right, so the first thing we're going to review is how to build an HADR 3-node cluster. And you can see here I've got a demo lab environment that you can actually go onto. If you go ahead and Bing just Microsoft Virtual Labs, you'll get a link that will take you to where this lab can be launched from. And then this is actually a real virtual environment that we've got 4 servers. We've got a SQL Server domain controller. We've got SQL 1, SQL 2, and SQL 3. And you can see we got a lot of different things that we can do each one of these servers. So what we're going to do is, like I said, we're going to build a 3-node cluster that is going to take a database and create an availability group around that database and using that database. And on top of that, we're going to build a virtual network name that we're going to actually write into DNS, which is why we've got our domain controller as part of our demo environment today. And then we're going to actually launch an OLTP application that will fail over, and we'll see what happens in the underlying architecture as that failover occurs. So the first thing we have to do in this environment is ensure that we've actually got our cluster built. And the core foundation and principle behind SQL Server Always On is built on top of Windows clustering. So we're going to launch our server manager, and this is going to allow us to take a look at the actual cluster health and make sure that all of the nodes are online and active in this environment. So select Tools, and then we'll go to our Failover Cluster Manager. It's going to take a second to load the snap in here. Here we go. Now we can see through our menus, and if we take a look at our nodes, that we have a healthy environment with SQL 1, SQL 2, and SQL 3, and they're all online and up and joined to our cluster. So full green across the board. Now I'm going to close Cluster Manager, and what we can do is now we can actually go into SQL Server and start to build our availability or our always-on availability group. So I'm going to go back to my search screen, and we'll just quickly launch SQL Server Management Studio. So everything that we're building here is actually built in the context of SQL Server Management Studio. It's our one-stop shop tool and has been for many years for any kind of database administration. Of course, we've extended some of this now into SQL Server Data Tools as well, which comes as part of SQL Server 2012. I won't get into the details, but we're definitely expanding our footprint a little in terms of functionality. And we'll go ahead and connect to SQL 1. So although we've got 3 different environments and 4 if you include our domain controller, we're actually going to do all of our work via SQL 1 today. And it's just going to go out and automatically connect and create the things that it needs to create on those secondary and third servers. So we'll go ahead and connect to SQL 1. Now we can review the databases that we've got in this environment. So we can see we've got a couple of copies of AdventureWorks, an always-on LabDB, some Contoso stuff up here. So we've got a report server. Looks like we've got reporting services deployed on this particular instance. So what we want to do is we actually want to create an availability group for our always-on LabDB. And so to do that, I'm going to expand. If we go down in the menu or the folder tree here, we can see we've got an always-on high availability folder. So if I expand this, see we've got something called availability groups, and I can right-click on availability groups, and I see something called a new availability group wizard. So I'm going to select that. And now we can start to configure our availability group. I'll click Next, and we're going to name this availability group Always On Lab AG. So the Always On Lab availability group. And now we can select the databases that we actually want to include in our availability group. And you'll notice that some are grayed out and some are selectable. we can actually include multiples. So differing from something like database mirroring, where we're selecting a single database to mirror, we can actually bring multiples together in groups, which is what's nice about the always-on capability. Now, you'll notice that some of these are actually grayed out. And what this means is that there's essentially a set of rules that each one of these databases needs to adhere to be considered for inclusion in an availability group. And one of those rules is that we need to have the recovery mode configured to full. And the reason for that is that SQL Server backs up and restores within the context of the recovery model for each one of these databases. So recovery models essentially are designed to control the behavior of the transaction log and that's associated with each database. And of course the transaction log is what's being used to manage the synchronous and asynchronous writes. And so, the recovery model is tracking, how are transactions logged? Will it allow backup? What kind of restore options are available? And so similar to database mirroring, availability groups require the full recovery mode. And you'll notice here that our always-on LabDB does not have the full recovery mode enabled. So we need to go ahead and actually turn that on. So let's just minimize our view here. And I can come over and we'll right click on our always-on database, lab database here, and we'll say new query. And I'm going to create this or change the configuration of the always-on LabDB just using straight command line. So just bear with me while I type this. So we're going to say use master, alter database, and we're going to select our database name. LabDB, and then we'll set our recovery context full with no wait. And so the last thing that I'm writing here is basically we're configuring a backup. And the thing that has to happen, very similar to replication, is the very first time that this goes out and actually creates the availability group, it's going to create a backup of this database on each server that we've designated be part of that availability group. So we're going to use our network share on SQL 1 for this. We'll name it always-on labdb.bak. Okay, I think this looks good. Just double check my syntax. Okay, I think we're looking good. So I'm going to go ahead and execute this command. You can see it's gone ahead and created our backup for us, and then it's also made our configuration change, so we're good to go there. So now I'm going to go back over to my availability group wizard and just quickly refresh. You can see now that always-on LabDB actually now meets our prerequisites. So I can select this. We can move forward. So this is where we actually define our replicas. So we've got our database group defined. And now we're ready to actually start adding replicas to this environment. So I've got obviously two other nodes that I want to include in this environment. And to do that, I'm going to select my add replica, and then we do SQL 1. We're going to change this to SQL 2 and click connect. There we go, SQL 3. We'll click connect. Okay, great. So now we've got all three of our replicas in place, and we can see that we've got some parameters that we can define for each one of these. And you recall that we can have two synchronous replicas per environment. So where we're going to select one, we'll make that synchronous. We'll select two, and we'll make that, and we'll set it up to automatically fail over between SQL 1 and SQL 2. In addition to that, I'm going to go over to SQL 3, and whoops, just refocus my window here. I've got the ability to actually define a readable secondary. And so we can choose which one of our servers will actually accept read requests. And in this case, we'll make number 3, our third server, as our server that manages basically our offline or our read-only reporting. So we'll click Next, and now we get to choose our data synchronization process. So you'll recall that I mentioned that there needs to be a copy of each database on every server across all of our replicas before we start. And what this is doing is it's actually going to automatically go out and create that copy for us. And it's just asking us what preference we would like. Would we like to do a full backup? It could be that we've already backed up and restored our database environment on those servers, outside of this wizard. So we have the ability to, join only, or actually even skip this process. So it's going to go through a set of checks and give us a stoplight report of where we can or where we need to make some changes. And the one thing that I'm noticing here, so we've got a check for compatibility of the database file location. So what this means is that essentially it's gone out and looked for a directory on our secondary and third server that it can store the backup in, and that directory just doesn't exist. So we need to quickly just go over to those servers and create that directory. So we're going to go ahead and do that. And to do that, I'm just going to take a shortcut here, and we'll click our Run menu. And we'll go to SQL 2, C $, we'll pull up the root of C here, and we'll create a new folder. AlwaysOn lab. I'm sorry, let's do AlwaysOn. And then within AlwaysOn, we'll create lab database. Great, so that takes care of SQL 2. Copy this, and we're just going to go back out. I want to do the same on SQL 3. And I'm just going to paste that same directory and copy it into SQL 3. So now we should have all of the appropriate directories in place. So let's rerun our validation. You can see here we've got all green except for this one warning. And what this is just basically warning us of is that we don't have a listener set up. So this is the virtual network name that I was talking about before that allows us to actually basically point an application to it and have the automatic failover occur seamlessly. And we're going to set that up in just a second, so I'm not going to worry about that. So we'll click Next and finish. And now it's going to go through and actually create our AlwaysOn availability group for us. We can expand our details node here and actually see what's occurring in real time. The fact that it's actually creating our backups and writing those to those particular servers and then making the configuration changes that it needs to. All right, great. So the wizard completed successfully. So now we can close this. And if I just quickly refresh, expand our database tree again, you can see here now that AlwaysOn LabDB is showing a synchronized state. So this just means that it's now part of that availability group and that it's ready to be highly available. Now, one thing that we haven't done yet is set up our virtual network name and our actual, what we call the availability group listener. And this is what's going to allow us to create that seamless or transparent connection to our availability group from our application's perspective. So if I expand now my AlwaysOn high availability folder structure, I can see here's the name of the AlwaysOn Lab AG database group. And then if I expand this, I've got a set of options where one of these is called the availability group listeners. and see there's nothing actually in there. If I wanted to expand this further, I could see the replicas that I've got in my cluster, SQL 1, 2, and 3, which databases we actually are making highly available. And there's nothing under our availability group listener, so that's what we're going to set up. So I'm going to right click and just select add listener. And our listener name will be AW Lab LSN, so short for listener. We'll create our default port for SQL 1433. And I don't have DHCP configured in my domain controller, so we're going to go ahead and just add an IPv4, a straight IP address here, 192. We'll do 168.1.235. Let's double check this. Okay, let's click OK. So this is actually going out up to our domain controller, and it's creating our listener DNS name and associating it with our IP address. Let's give this a couple more seconds. And while this is happening, I'm going to launch our command line. And I just want to make sure that our listener has been configured, so I'm just going to quickly ping it. You can see here I've pinged AW Lab LSN, and we're getting a reply from the IP address that we created. So it looks like it's set up. Okay. So let's now take a look at manually failing this over. We're going to obviously set up our OLTP application in just a minute, but I wanted to show you how easy it is to manage and maintain this high availability group using our dashboard. So you can see we've got our availability group here, and we right click it again, and I've got an option to show a dashboard. This is going to bring up a screen of basically all of our nodes in our availability group. We've got SQL 1, SQL 2, and SQL 3, and we can see the role that they're playing. Obviously, we defined a synchronous synchronous write between SQL 1 and SQL 2, and SQL 3 is acting as our report server, and that's in an asynchronous mode. So you can see it's constantly in a synchronizing state. It's never quite caught up with SQL 1 or our primary database. You can see we've got some groups that we can create here. And what I wanted to draw your attention to is the wizard that we have in the right-hand corner here. And we've got an option to actually start Failover Wizard. And this is where we get into some of the nuances as it relates to ease of use for failing over. So we can start this nice wizard to fail one of the servers over. And SQL 1 is currently our primary replica. And this is actually giving us some data around each one of these, or the current state of each one of these replicas. And we take a look at SQL 2. We can see that the failover readiness we've got a nice green check mark. There's no data loss, and this is obviously, of course, because we've got synchronous, failover configuration set up between this, so we're not going to have any data loss. SQL 3, it's giving us the ability to fail over to it. We could select it if we wanted, but it's saying that there could be a potential data loss based on the fact that it's an asynchronous connection. So in this case, I'm going to fail over to SQL 2. Click Next. Of course, we'll have to connect to it and provide credentials to do this. Click Next again, and then we'll finish this up. And so what this is doing, and if we look in the background, it's we should hopefully see this change state. Sometimes the refresh rates are slightly different, but it's actually failing over to our SQL 2, and there we have it. And you can see SQL 1 is showing as offline. This will come back up in just a second as the refresh. Maybe I can actually do a manual refresh here. Yeah, there we go. So SQL 1 is now back online. Its role has changed. It is now our secondary server, and you can see it's gone down. We've dropped down to 1 because it's not basically one server view in this dashboard, because SQL 1 is no longer our primary. It's acting as a secondary. All right, so that's in a nutshell, how you would fail over a server in our environment. So let's now launch an actual application that is going to write to our server, or our cluster, and then let's initiate a failover. So from here, I'm just going to minimize my SQL Server Management Studio for a second, and I've got an application that has been loaded onto this server and into this environment called just an OLTP application. I'm going to launch this so we can see what's going on. All right. So I can see underneath the window here we've got provider data source. We have the ability to control what this particular application connects to from a SQL Server perspective. And what this will allow us to do is it's going to just do some random writes into our database structure. And so to enable this, the first thing that I want to show you is that if we change our data source here, so we know that based on our recent failover, that SQL 2 is now our primary database. And so if I change the connection, you can see we're connected to, if we take a look at the properties up on the top here, connected to AlwaysOn LabDB on SQL 2. And so I can actually begin some read and write, so we can see we've got a certain number of inserts per second that are happening and how many rows are actually being written. You'll notice that we're still using SQL 2. So what I want to do now is actually show you that in addition to SQL 2, we also have our listener configured. And so let's actually change the connection string to AW lab which was the listener that we had created, and select the change button. And you'll notice up at the top here that even though we've changed our data source connection here, and we named it AW lab we're still connected to AlwaysOn Lab on SQL 2. And if I begin my writes again, my writes are occurring. And now this is seamless. The actual application, or the database itself, or the database server, sorry, itself is totally transparent to the application at this point. So let's fail this over now and see what happens. So recall that we've got automatic failover between SQL 1 and SQL 2. And if I launch Management Studio again, and let's select SQL 1, and we're going to write new query, and we're actually going to do a syntax-based failover. So we're going to say alter availability group, and then AlwaysOn lab AG is the name of our availability group, and then we're going to say failover. And let me just focus this so that we can see the application in the background. A little bit of screen refresh here. Okay. So let's go ahead and kick off this failover. Okay, so you'll notice I've executed this, and let's refocus our OLTP application. You can see here we've got some connection failure retries that are occurring. So in the background, our failover has occurred, and already in a few short seconds, it's now picked up our secondary node. So now we're connected to, if we take a look at our string up here, we're connected to AlwaysOn LabDB, and that's actually showing connection now to SQL 1. So with very little effort, we failed this over. The connection picked up very, very quickly, and is rolling along again. So that really illustrates the speed and ease at which we can initialize some of these failovers. So I'm going to close this. Now let's just navigate back over to our dashboard and launch this again. And you can see our dashboard has updated itself again, and we've got SQL 1 is designated as our primary server again. So just completely reversed roles. All right, so just to get into the final piece of the demo here, so that really is the full demonstration of creating an availability group, building it, failing it over manually, failing it over via code. I could have easily gone in and just taken the SQL Server service and actually stopped that. So it would have been many different ways we can manage these types of failure points. And of course, obviously, if the machine itself fails, based on a set of business rules that you define, that would enable failover as well. Let's, as a final demonstration here, I'm just going to minimize that and let's close our OLTP application. Let's launch a reporting application, and I want to show you some of the capability around reporting. So once again, we have the ability to control the connection string. So this is a basic reporting application. You remember that we set up SQL 3 as our read-only database. And so let's go and connect to SQL 2 and see what happens. Okay. So you'll notice that it's basically giving us a warning. It's saying the target database, AlwaysOn LabDB, is participating in an availability group and is not currently accessible for queries. So yeah, just pointing out the fact that we have not, in fact, enabled that particular database for read-only. So I can quickly make that change, and I could easily, designate SQL 3 in here if I wanted to, but I wanted to show you how to change it in the wizard. And it's as easy as right-clicking on our availability group, selecting Properties, taking a look for SQL 2, and there we have it. And let's define this as a readable secondary. Click Yes, and click OK. It's going to go through that change. Now let's launch our reporting application again, and select Change. And you can see now we're actually connected to our AlwaysOn LabDB on SQL 2. And we can kick this off, and it's going to actually start returning returning rows and records from that particular database. So that is really the end of our demo today. So we've shown you how to build a 3-node availability group, make some configuration changes to both the databases and the environments, initialize failover in multiple ways, and then also connect an OLTP application and see how the failover occurs and impacts the environment, as well as launched a reporting application and showed you how the read-only workload would work in this type of configuration. So I'm going to just quickly jump back over to my slides here. So I'm going to go back to my PowerPoint presentation. And I just want to bring up this slide again just to remind you. Give that a couple seconds to hopefully show up. So essentially, I just wanted to review our gov.sql training program. So this was the first, as I mentioned, in a few different webinars that we've got. We've got a few more coming up for the next couple of weeks on tabular BI, as well as on big data. And Josh will be running that particular webinar. But essentially, just this is an opt-in program. You guys are welcome to attend. This is going to be posted on YouTube. This video will be, so anybody that sees this on YouTube and is interested in learning more as well and is in the government sector in the Southeast or anywhere else actually in the US for that matter, please let me know. Please feel free to email me. We'll be conducting web-based training events. I'll also be emailing on occasion if we've got product patches and releases and things like that. So thank you very much for joining us today. That concludes my presentation, and we'll talk to you soon.